Have you ever wondered how psychologists can look at human behavior and pull out these incredible insights? It's not magic, I promise you. It's statistics. And look, don't let that word scare you off. Don't think of it as some dry, complicated math class. Think of it as a secret language, a powerful tool that lets us see the hidden stories in the data all around us. Okay, let's crack this code together.
All right, so picture this. Researchers are doing a study on how much time teenagers spend on their smartphones. They gather all this data, and what they end up with is, well, this. It's just a jumble of numbers. 15 hours, 22, 40, 55. It's a mess. Right now, it's just raw data. It's noise. It doesn't really tell us much of anything, does it? So that's the big question, right? How do we get from this chaos of numbers to some kind of actual clarity? How do researchers find the real story, the signal that's buried in all that noise? Well, the answer is statistics. This is the researchers' toolkit. It's how they take all that raw, messy data and transform it into actual, useful information. It's the first step to organizing the chaos so they can understand what's really going on and maybe even make some predictions.
So, where do you even start with a pile of numbers? Well, the very first thing a psychologist wants to do is find the center of it all. They're looking for one single number that can represent what's typical for the whole group. To do that, we use something called measures of central tendency. I know, it sounds super technical, right? But the idea is actually really simple. We're just trying to find the middle, and we're going to look at a few key tools that help us do just that. First up is the one you probably already know, the mean. This is just the good old-fashioned average. You literally just add up all the numbers in your set, and then you divide by how many numbers you have. Simple as that. Let's just make this real for a second. Look at this simple set of numbers: 10, 15, 20, 25, and 30. Okay, step 1, add them all up. That gives us 100. There are 5 numbers total, so we divide 100 by 5. And boom, the mean is 20. Easy, right? But the mean has a secret weakness. Let's go back to our teen smartphone study for a second. Remember that one student who's on their phone for 55 hours? That number is what we call an outlier. It's an extreme value that's way different from the rest. And a score like that can really pull the mean, the average, way up, giving us a kind of distorted picture of what a typical teen is doing. So what's the fix? We bring in our next tool, the median. To find the median, all you do is line up your numbers from smallest to largest and find the one that's sitting smack dab in the middle. It's the true middle ground. And that 55-hour outlier, it doesn't really affect the median. The median just hangs out in the center, unbothered. So here's the deal. The mean is the mathematical average, and it's great because it uses every single piece of data. But that's also its weakness. It gets easily pulled around by those extreme outliers. The median, on the other hand, is the physical middle point. It's tough, it's resistant to those outliers. So here's the key takeaway. If your data has some really wild, extreme scores, the median is often going to give you a much more accurate story. Okay, finding one number to represent the center is a fantastic start, but it doesn't really tell you the whole story. To get the bigger picture, you got to step back and look at the actual shape of the entire data set. This is where things get really interesting. And this is the most famous shape in all of statistics, the normal distribution, or as everyone calls it, the bell curve. You see this shape everywhere. A perfect example? Just imagine lining up all the students in a school by height. Most kids would be clustered around the average height in the middle, and you'd have fewer really short kids on one end and fewer really tall kids on the other. That's a bell curve. But of course, data isn't always so perfectly symmetrical. Sometimes you get this, a positive skew. A great way to think about this is community income. Most people might earn a similar amount, but then you've got a few billionaires, and their massive incomes pull that tail way, way out to the right. This is exactly why you always hear news reports talk about the median household income, not the mean. And as you can probably guess, the exact opposite can happen too. With a negative skew, most of the scores are piled up on the high end, but you have a few really low scores that drag that tail out to the left. See? The shape of the data itself is telling us a story. Now, check this one out, because this is fascinating. This is called a bimodal distribution. You see those two distinct peaks? For a researcher, seeing this shape is like finding a major clue. It's yelling at you that you probably don't have one cohesive group. You've got two different subgroups mixed in together.
And that's exactly what the source material points out here. This pattern shows us something more complex is going on. Maybe in our smartphone study, one of those peaks is screen time during the week, and the other peak is screen time on the weekend. The shape itself is revealing a hidden pattern in the data.
Okay, so we can describe our data, we can see its shape, but now we've arrived at the single most important question in all of research is the thing we found a real effect, or did it just happen by random chance? And this brings us to the huge concept of statistical significance. It's basically a test researchers run to see if their result is the real deal. They're asking, what are the odds that I would have gotten this result just by pure dumb luck?
And in the world of psychology, here's the magic number. P is less than 0.05. That P just stands for probability. So if the probability that the result happened by chance is less than 5%, or a 1 in 20 shot, researchers get to say their finding is statistically significant. It's kind of like the gatekeeper for getting your research published.
But wait, and this is so important. Statistical significance just tells you if an effect is probably real. It does not tell you if that effect is important or meaningful. That's where practical significance or effect size comes in. Think of it this way. You could find that a new therapy is statistically better than an old one, but if it only helps people improve by a tiny 1%, does it really matter in the real world?
Finally, it's so important to remember that no single study is ever the final word. Science isn't about one person's discovery. It's a massive team effort. So how does the whole field of psychology put all these individual pieces together to build a big, solid conclusion? They do it with an incredibly powerful tool called a meta-analysis. This is literally a study of studies. Researchers go out and gather up all the high-quality research on one specific topic, they pool all that data together, and then they analyze it all at once. This gives them a way more powerful, more reliable conclusion than any one study could ever hope to provide on its own.
So, at the end of all this, why does any of it matter to you? Because now you have the toolkit. You have the secret decoder ring. The next time you see a headline about some new scientific study, you can ask smarter questions. You can think, I wonder if outliers skewed that average. Or, okay, it's statistically significant, but how big is the effect size? You can start to see the story that the data is trying to tell.
Because that's what it's all about, really. Data isn't just a boring pile of numbers. It's a story. It's always telling a story, waiting for someone to uncover it. And now, the real power is in your hands, because you know which questions to ask.